Today we're talking about operations with radicals. So what I mean when I say operations is addition, subtraction, multiplication, and division. Those are our four operations, so we're going to be using those operations with our radicals today and learn how to do that. We've seen this plenty of times before. It's talking about simplest form of a radical. We've talked about these first 2 points. The first one, no radicands have perfect nth powers as factors other than 1. That was our product property, where we could split up a square root and a product under the square root and let each factor have its own square root. Such as the square root of 45 equals square root of 9 times 5, which equals the square root of 9 times the square root of 5. That's what that first point's talking about. The second point is no radicands contain fractions. That was our quotient property. So if we have the square root of 2 over 25, the quotient property said I could give the numerator its own square root, the denominator its own square root, and then simplify each fraction, or each radical. Today we'll look a little more in depth at point number 3 here, as well as some other things besides just point 3. So let's get into our operations. Radicals with the same index and radicand are called like radicals. Now remember, if I have a radical, this little number right here, this n, is our index. If it's a square root, it's understood to be 2. A cube root, there's a 3 there. Fourth root, there's a 4 there. It's just telling us which root to take of our radicand. Our radicand is this number or variable underneath our radical. So for them to be like radicals, the index has to be the exact same and the radicand has to be the exact same. So if I have the square root of 3 and the square root of 3, those are like radicals because they have the same index and the same radicand. If I have the cubed root of 3 and the square root of 3, those are not like radicals because one has an index of 3, the other has an index of 2. If I have the square root of 5 and the square root of 6, those are not like radicals. While they do have the same index, they do not have the same radicand. So they are not like radicals. Now let's say I give you 2 times the square root of 5 and 5 times the square root of 5. Those would be like radicals because the radical has the same index on each of them and the same radicand. The 2 and the 5 out front, those are just numbers being multiplied by my radicals, so these are still considered like radicals. So let's talk about addition and subtraction. You can add and subtract like radicals the same way you combine like terms. So if you remember, we have like terms. For this expression right here, that would be 2x and 3x. I add the numbers in front of my variables. 2 plus 3 gives me 5. I keep the variable that's with both of them. And that would be me combining like terms. Similarly, let's look up here. If I have 2 square root of 2 plus 3 square root of 2 plus 4, I'm treating it the same way that I treated this expression down at the bottom. I have like radicals. The square root, they're both square roots, so they have the same index, and they have the same radicand. So these are like radicals right here, and I can combine them. 2 plus 3 gives me 5. I keep the square root that they both have, and there would be my simplified expression. Very similar to combining like terms with just variables. So let's look at some examples. Letter A, we have 10 square root of 5 plus the square root of 20. Now, as of right now, these are not like radicals. They have the same index, but they do not have the same radicand. The first thing I need to do before I do anything, though, whenever I'm adding and subtracting radicals, is to make sure both radicals are all the way in simplest form. So I need to simplify both of them if I'm able to. This first one, 10 square root of 5, is already simplified, so I don't need to do anything with that one. The square root of 20, however, can be simplified further. So we're looking for the biggest perfect square that goes into 20. That would be 4. 4 times 5 gives me 20. Taking the square root of 4, I get 2, so I can pull that out of the radical. And then I cannot take the square root of 5, so it has to stay under the radical. So the square root of 20 simplifies to 2 square root of 5. So letter A becomes 10 square root of 5 plus 2 square root of 5. Now I do have like radicals. My radicals have the same index. They also have the same radicand. So I'm just adding the numbers out front. 10 plus 2 gives me 12. Keeping the same radical that they both have. There's my simplified answer. Like I said, very similar to combining like terms when we just have variables. Let's look at letter B. We have 6 square root of x minus 2 square root of x. Right off the bat, we have like radicals. My radicals have the same index as well as the same radicand. So I can go ahead and subtract right off the bat. 6 minus 2 gives me 4. I keep the radical that they both have. There's my simplified answer. Hopefully that makes sense. Hopefully it's pretty easy for y'all. I feel like it is. Just make sure all your radicals are simplified before you start trying to add or subtract. Now let's look at multiplying radicals. Letter A is the square root of 14 times the square root of 7. Before we jump into letter A, I want to refresh y'all's brain on something a little bit. If I have the square root of 45, remember we looked for the biggest perfect square that goes into 45. That's the square root of 9 times 5. 9 is the biggest perfect square that goes into it. My product property says that I can split 9 and 5 into their own radicals just like this. That's the product property from a couple weeks ago. If you notice, letter A looks kind of similar to the square root of 9 times the square root of 5. So for letter A, I can kind of work backwards this way from what I did for the square root of 45. So I can rewrite this as the square root of 14 times 7. And then multiplying 14 and 7, I get the square root of 98. So if I'm multiplying a square root times a square root, I can just multiply the numbers under the radical. It doesn't matter if they're like radicals or not. Excuse me. I just need to multiply the number under the radical. Now I'm not done with letter A yet because the square root of 98 can be simplified. Square root of 98, the biggest perfect square that goes into it would be 49. 49 times 2 gives me 98. Square root of 49 is 7, so I can pull 7 out of the radical. I cannot take the square root of 2, so it stays as the square root of 2. So 7 square root of 2 would be my simplified version of my product up here, the square root of 14 times the square root of 7. So multiply your numbers under your radical, simplify your radical. Now let's look at letter B. We have the square root of 5 times the the square root of 3n minus the square root of 75n. First thing I need to do is distribute my square root of 5 inside my set of parentheses. So the square root of 5 times the square root of 3n gives me the square root of 15n. Once again, just multiplying my radicands, the numbers under the radical. Minus square root of 5 times the square root of 75n gives me the square root of 375n. Excuse me. So now I have a subtraction problem with radicals. So once again, the very first thing I need to do is to simplify my radicals all the way down. This first one over here is already in simplest form, so I don't have to do anything to it. The biggest perfect square that goes into 375 is 25. 25 times 15 times n gives me 375n. Square root of 25 is 5. That's the only thing I can take the square root of. The 15 and the n have to stay under the radical. So this becomes the square root of 15n minus 5 square root of 15n. Now I have like radicals. My index is 2 because it's a square root. My radicand is 15n for both of them. They both have the same index and same radicand, so they are like radicals. So I can subtract here. Just like with a variable, if there's no number in front of my radical, there's understood to be a 1. So 1 minus 5 gives me negative 4. And then I keep the square root that they both have. This is already in simplest form, so there's my answer for letter B. Now I want to show y'all another example real quick. We'll call it letter C. Let's say I had 2 square root of 3 times 4 square root of 5. Now I have numbers in front of my radicals. That's okay. I just have to multiply the numbers in front of the radical. That gives me 8. Then I multiply the numbers under the radical. That gives me square root of 15. So if you have numbers out there, don't worry. It's still pretty easy. Multiply the numbers outside the radicals. Multiply the numbers inside the radicals. Let's move on to division. Now over here on multiplication, if we had numbers outside our radicals, we multiplied them. Multiply the numbers inside the radical. I'm going to do the same thing here except with division. I'm dividing the numbers outside the radicals, so 3 divided by 12, and I'm dividing the numbers inside the radicals. So 3 divided by 12 would just be a fraction. It would simplify to give me 1 over 4. 3 over 12 simplifies to give me 1 over 4. 10 over 30 simplifies to give me 1 over 3. So make sure that 1 stays under a radical, that 3 stays under a radical. So it's very similar to multiplication. I'm just dividing. Divided my numbers outside the radical, divided the numbers inside the radical. Now up top of my numerator, I have 1 times the square root of 1. Well, the square root of 1 is just 1. 1 times 1 gives me 1. So I get 1 in the numerator, and then I get 4 square root of 3 in my denominator. Some of you may want to stop there. That is not my answer, however. If I look back at the simplest form of a radical, we're looking at this bottom point. It says no radicals appear in the denominator of a fraction. So it's not in simplest form because I have a radical in my denominator. So let's look at something real quick. If I have the square root of 5 and I multiply it by itself, that's going to give me the square root of 25, which is just 5. So anytime I multiply a radical times itself, my solution is going to be my radicand. It's just going to eliminate my radicals. So that's what I need to do to be able to eliminate my radical in my denominator. I'm going to move my work over here. I need to multiply the part that has the square root of 3 in it by the square root of 3. So it'll get rid of that radical. Whatever I do to the bottom of a fraction, I have to do to the top. So up top I get 1 times the square root of 3, which is just the square root of 3. Downstairs, remember, if I have a number outside the radical, I multiply them. There's understood to be a 1 there. 4 times 1 is 4. And remember, when I do the square root of 3 times the square root of 3, I'm just going to get 3 out of that. Square root of 3 times the square root of 3 gives me the square root of 9, which just turns into 3. Now I can simplify this a little bit. I get the square root of 3 over 12. And there'd be my answer. Hopefully this is making sense to you guys. If you have any questions about it, feel free to email me, send me a message on Canvas, or remind, or ask me about it in class. Here is our assignment, page 299, numbers 75 through 92 all. It's going to be posted to Canvas for you to turn it in on Canvas. I hope you guys have a good evening. I will talk to y'all later.